That one's really up there. What it is, what it can do, and where it came from is a vital chapter in modern American achievement. Where did it come from? Let's follow this transport plane and find out. This is the desert of western Nevada, already well known for its nuclear tests by the Atomic Energy Commission here at Yucca Flats. Adjoining this AEC test site is an active aerial gunnery range. Early in 1955, by presidential order, 60 square miles of this prohibited area were set aside for a special purpose. There's a narrow air corridor to reach this spot on the map. Air charts order closed to all personnel and aircraft except on orders from the Chief of Staff, U.S. Air Force. The name of this isolated spot in Nevada is Watertown, and its very isolation is of the greatest importance. The specialists that come off this transport are hand-picked. They are checked every time they arrive at Watertown. Overall security in this area is the highest yet to be maintained in this country, even higher than that of the Manhattan Project. Selection of Watertown was dictated by several unique considerations. The area is isolated from prying eyes by the AEC range, with lethal reminders of past atomic explosions. AEC guards maintain regular patrols. Supplies destined for Watertown channel into the area through regular AEC routes. Watertown is an ideal security area. Of prime importance, however, is the 25 square miles of smooth clay known as Groom Lake. 19 different western dry lakes were surveyed before deciding on this spot. The base at Watertown was built in 90 days, complete with hangars, ramps, and runways. Air-conditioned buildings, living quarters, power and water. The whole reason for the existence of Watertown arrives in the cargo hold of this transport. Here at Watertown, men can develop almost any project and still keep its very existence under wraps. It was here that this new aircraft was assembled and flown for the first time, just 8 months after the contract was let. It was here that the world's jet altitude record was broken and broken again on every high flight. Because she goes so high and so far, the men who work on her have named her the Angel, though on the books she's called the U-2. As an aid to security in radio and teletype communications, the Angel is referred to as an article. Her pilots are called drivers. The geographical spot of Groom Lake is called home plate. The Angel was designed to do a single job: obtain the largest amount of reconnaissance information ever collected on any single flight. For the first time in jet history, it is possible to inspect 400 square miles with a single cartographic photograph. For the first time in jet history, sensitive electronic equipment is being carried to heights where it can search for any number of radio, TV, or radar signals and record this information for detailed analysis. There are already 12 alternate equipment loads for the U-2. Development of the Angel and the information-gathering equipment that it carries is the result of the most experienced judgment applied at every critical point. A select group of capable, dedicated men in industry and government, working with trust and cooperation, completed this specific project at the utmost speed. The idea for the Angel itself was born when Lockheed started a design study on the maximum altitude possible from a jet air, and Lockheed's chief engineer, Kelly Johnson, called together his tiny 26-man Special Projects Engineering Group. Here were the problems they faced: to design, build an airplane, and fly it in 8 months. An airplane that would cruise well above 70,000 feet. One that would travel almost as far as a B-52 and remain in the air for 10 hours. A plane that would be completely reliable, with forced landings out of the question. A plane that would be the world's most stable aircraft for high-altitude photography. A plane that would be flexible in concept, to carry at least 12 different equipment loads and have no one penalize the others in weight. A plane that would weigh only 1 1/2 times the weight of the power plant. Weight was the critical factor in the whole project. Designers said they would trade their collective grandmothers for 10 pounds of empty weight. Pounds, in fact, were called grandmothers. But weight could not be saved at the expense of reliability, a real engineering challenge, met with proven know-how and a basic design so simple that it was almost revolutionary. The Angel is simplicity itself. All control surfaces are cable-operated. The tail section of the fuselage attaches with only 3 bolts. The inside of the 80-foot wing is just 4 big fuel tanks. The interior of the fuselage is plain and uncluttered. The cockpit canopy, stressed to handle a pressure differential of 5 pounds per square inch, is operated by hand. The pant leg engine intake ducts presented a problem. At altitude, near-perfect ram air distribution was needed to keep the engine running. The final intake on the Angel gives as good pressure distribution as would be found in a power plant wind tunnel. A unique gust-relieving feature was designed into the wing of the Angel to reduce tail loads and wing bending in turbulence. The flaps tilt 4 degrees upward, and the ailerons tilt 10 degrees to completely change the airfoil characteristics. During development of the Angel, Kelly Johnson met with each member of the Special Projects Group at 7 every morning. Any problems occurring on the previous day were discussed and corrective decisions were made immediately. Subcontracting was virtually impossible. 87% of the prototype Angel was fabricated in one building in Burbank. Components were run through the company's big presses at night and on Sundays, then hidden from day shift workers. The C&J Manufacturing Company, for Clarence Johnson, was formed in an unmarked downtown warehouse to handle shipments from vendors in unmarked trucks. Designers of the Angel couldn't even get into a high-speed wind tunnel, so calculations were made with computers. 50% of production took place in this building at Bakersfield. At peak production of the 50 U-2s, only 600 people were involved, just 1 man in every 60 on the Lockheed payroll. The Angels were completely assembled here, checked out, disassembled, and shrouded in canvas for airlift to Watertown. Fuel and hydraulic fluid were added for the first time at Watertown, and the Angels were tested by company pilots. Because of its long, thin wings, the Angel has been referred to as a jet glider. It has the world's most efficient lift-drag ratio for powered aircraft, 25.6 to 1. That's better than many competition sailplanes. From 70,000 feet, the Angel can glide 300 miles without power. The engine for this aircraft was originally the Pratt & Whitney J57-37, a 10,500-pound thrust unit built for the B-52. A later 11,500-pound version, known as the -31, was developed specifically for the Angel. Pratt & Whitney President Jack Horner and Chief Engineer Wright Parkins crammed a normal 3-year engine development program into 12 months. The new engine has a 16-stage compressor with 9 stages in the low range and 7 in the high-pressure chamber. The low-range compressor is driven by a hollow shaft and turns at a lower speed than the high compressor. The Pratt & Whitney engine operates at full power for the duration of the flight. At sea level, this unit gulps nearly 9,000 pounds of fuel per hour. At 70,000 feet, this drops to 700 pounds per hour. At 74,600 feet, the engine will quit from oxygen starvation. In early stages of the program, as many as 6 flameouts occurred on a single flight. With the new fuel system and turbine design of the -31 engine, Flameouts have ceased to be a critical problem. An improved ignition system ensures air restarts at high altitudes. In the first 20 months that the Angel flew, logging over 5,000 hours in the air, there were just 2 forced landings away from Watertown. Both planes, equipped with the older Dash 37 engines, landed at Kirkland Air Force Base, Albuquerque, New Mexico. After each development flight, a careful accounting is made of fuel consumption. A special fuel dubbed lighter fluid was developed by Shell Oil Company specifically for the Angel, and the finished product was shipped to Nevada in tank cars labeled LF-1A. This blend will not boil at the low pressures encountered at altitude, yet will still give adequate air starts. It is so involatile that fire seldom follows a mishap. A simple 100-gallon slipper tank has been developed to fit each wing for extremely long flights. These pressurized tanks contain enough fuel to carry the Angel to cruising altitude, where they have no significant effect on speed or range. Even after the addition of an external drag chute, 3 times the normal oxygen supply, improved braking, and an autopilot, the final all-up weight was within 10 pounds of the original proposal. The Angel exceeded original performance limits in both ceiling and range. When the prototype Angel was flown across Death Valley to Watertown, Lockheed also found itself in the transportation business. Their own DC-3 made almost daily flights to Watertown with a hand-picked crew of flight line mechanics. The first unofficial name for Watertown was Paradise Ranch. This description was dreamed up tongue-in-cheek to encourage key personnel to accept assignment on this special project before they could be told what it involved. Anyone for golf? Many newcomers guessed that the project involved an atomic-powered aircraft and were astonished to find that they were to work with straightforward, conventional jet aircraft of the highest performance. The Angel first flew from the surface of Groom Lake on August 2nd, 1955. However, it wasn't planned that way. These scenes from the company's files show Lockheed Chief Test Pilot Tony Levere taking the Angel out for taxi tests. On the second taxi run, the U-2 popped into the air to 36 feet and then dropped in so hard that it blew both tires on landing. During rollout, the brakes caught fire but were quickly extinguished. 2 days later, in a rainstorm, the Angel went to 8,000 feet. That day it took 5 attempts to land the plane because it would fly on idle engine thrust. The unusual bicycle landing gear, designed for the lightest possible structure, weighs 257 pounds. A conventional gear on a comparable aircraft would weigh 750 pounds and take room out of the wings that is vital for fuel. Wing-mounted pogos drop off during takeoff, again in the interest of saving weight. Weight and space that paid off in an extra 1,500 feet of altitude and 100 miles in cruising radius. As the operation at Watertown grew in scope, more transportation was required. A daily military air transport shuttle system was begun with C-54s from Burbank. In bad weather, one of these transports crashed into Charleston Peak, a few miles north of Las Vegas. 14 members of the Watertown project were aboard. The program has not been without other casualties. One Angel crashed at Watertown. Another disintegrated over an Indian village named Wide Ruin in Arizona. A third, with Lockheed pilot Robert Seeker aboard, disappeared near Watertown. By the time this plane was found, some information about the project at Watertown reached the public. this nearly 3 years after its conception. That dust cloud is an actual crash. Rescue crews rush to the end of the runway where an Angel has landed short. The pilot here was uninjured, but emergency crews take no chances with leaking fuel. Salvage operations mean that this fallen Angel will soon fly again to rejoin its sister ships already in the air. This project has had fewer mishaps than is normal with new aircraft, yet unique ground handling equipment designed solely for the Angel operates as well at this crash scene as it does on the flight line. Not all the difficulties at Watertown have come from the Angel herself. Extremes in weather, wind, sand and heat, snow, cloudburst, biting cold, an ever-present headache, but the Angels must be ready for tomorrow's flight. It's almost all work and no play for the temporary desert dwellers at Watertown. Just 72 airline miles distant is Las Vegas. However, none of Watertown's workers can visit these bright lights or refreshing scenery. Security is just that rigid. Meanwhile, back at the ranch, volleyball, pool, a 16-millimeter movie, and a tiny converted mess hall are just about the only diversions. Those who remain over a weekend may explore long-deserted gold mines. Remnants from another era of rugged desert pioneers. Since the Angel is a one-man airplane, the devices normally operated by a 3 to 6-man crew must be crammed into the tiny cockpit. This complicated periscope sextant, developed in 6 weeks by Dr. Robert Hills, Jr. of Baird Atomic Incorporated, attaches firmly to the airplane so that the pilot need not turn around in the cockpit. A navigational trainer is used for pilot familiarization. For long-range navigation, the sextant is coupled with the Perkin-Elmer drift sight that doubles in brass as a viewfinder for reconnaissance cameras. By pre-computing star angles or sun angle for any course, a pilot may navigate without resorting to involved calculations. The complete optical system is filled with dry nitrogen to prevent condensation. The primary objective of the Watertown project and development of the Angel herself was to obtain the maximum reconnaissance information possible from any single flight. Hycon Manufacturing Company was selected to build a series of 4 photographic systems to fit the equipment bay of the Angel. The company faced the problem of producing equipment that would operate completely unattended for the full mission of the Angel and bring back negatives of resolution at least 3 times better than the best existing equipment. Hycon's Special Project Group, under the leadership of Vice President William McFadden, drew key personnel with a long background of reconnaissance camera work from other company projects, just as other groups siphoned their most talented people into this program. H.C. Silent, one of the nation's outstanding electronic and photographic engineers, made major contributions to the early stages of the project. He was aboard on the Mount Charleston shuttle crash. Hycon cameras feature lightweight, high-resolution aspheric lens elements, contoured platens to retain the high resolution, and film capacity up to 12,000 feet. First of the reconnaissance installations, the A-1, really consists of 4 separate cameras. 3 6-inch wide-angle cartographic cameras are mounted, one vertically and 2 at 56 degrees. The A-1 gives horizon-to-horizon coverage on 3 9x9-inch negatives. This TriMet installation of cartographic cameras can be used for small-scale mapping of large areas. In conjunction with the TriMet group, a 24-inch rocking mount camera records medium-scale intelligence information on 9x18-inch film. A single photograph from just the vertical cartographic unit will cover a 400 square mile area, while a vertical negative from the 24-inch lens covers a 5x10 mile area. The complete unit, with film enough for a 3,000-mile flight with stereo overlap, weighs only 339 pounds. Each Hycon camera system has image motion compensation to cancel the forward speed of the aircraft and maintain the high resolution of film and lens. The A2 camera configuration consists of 3 24-inch units similar to the large camera of the A1. The center camera is mounted vertically, the others at 37 degrees from the vertical. These photographs were taken by an A2 camera unit over Sacramento, California. Details smaller than 4 feet can be recognized as demonstrated by these 4 and 10 diameter enlargements. With their 1,800-foot film capacity, the 3 A2 cameras will photograph a strip over 2,000 miles long and 37 miles wide with 55% stereo overlap. One of the most unusual reconnaissance cameras ever to be developed is the B camera system. The B is an entirely new concept in camera design and violates virtually every taboo in the business. In a completely new reconnaissance concept, the lens, cone, and mirror of a camera are rotated to any one of 7 positions from vertical to the horizon on either side, covering a path 750 miles wide on a single flight. The B camera can be preset to any one of 4 exposure patterns. It can swing horizon to horizon in 7 exposures, shoot a series of 3 vertical and near vertical pictures, pattern 3 more on a high oblique angle to either side, or be set in a fixed position. In only 12 missions, all the significant intelligence and physical information of the entire United States could be recorded with the overlap needed for stereo evaluation. The B configuration carries a 36-inch lens to cover an 18 by 18-inch format, which portrays a 6.6 mile square of the ground from the vertical. Here is a 10 diameter enlargement taken from 13 miles high, which clips One of the key contributions to the whole program was the development of a completely new aerial film by the Eastman Kodak Company, specifically for the cameras of the Angel. Dr. Cyril Stout and Fordyce Tuttle of the Eastman Kodak Company directed the project. Less than half the thickness of previous film, only 32 10,000ths of an inch, this new film is higher in red sensitivity than most and will cut through more haze. Use of standard aerial film would have reduced flight line coverage by 50%. With this outstanding new Eastman film, reconnaissance photos may be made during all the daylight hours. This thin-based film won't work in just any camera. Only a carefully designed system will guide the film properly. One of the really significant developments in camera design is the drive mechanism to handle this new thin-based film. It was virtually impossible prior to this development to transport aerial film of this thickness with any reliability. The B camera, for instance, transports over 2 miles of film from its 2 cassettes. This requires meticulous film manufacture careful spooling, and the closest tolerances in film transfer. To keep the center of gravity from moving during flight, one roll at each end of the camera is loaded with up to 6,000 feet of 9.5-inch film, run in both directions with a 1/4-inch gap between the two film pads. Thus, the center of balance of the camera is the same, no matter how many exposures have been made. The film moves continually through the camera at a fixed speed. However, like a movie camera, the film behind the lens is held stationary during the instant of exposure, while at the same time, a vacuum holds the film tightly against the contoured platen. To assure rigidity, the rotating portion of the B camera was made of formed thin steel. Originally, a vibration detector was used to trip the shutter at the instant the Angel was most stable. This 3-axis rate detector analyzed all movement and told the camera to fire at the most favorable time. However, the Angel has proven such a stable camera platform that this unit is no longer necessary. The 7 windows of optically flat glass in the B camera hatch are cleaned and window covers installed before flight to protect the glass from dust and condensation. These hatch covers are later jettisoned at altitude. The A1, A2, and B cameras have been designed to bring back general intelligence information, and their shotgun inquiry is meant to cover relatively large areas. Once an area of interest has been found, a follow-up flight is needed with the new C camera system, which gives 5 times the detail of the B camera. This camera is considered the ultimate in photographic equipment for the Angel. With well over 2,000 moving parts, it is undoubtedly the most complicated and versatile piece of reconnaissance equipment ever to be airborne. The C unit has an intricate 180-inch focal-length optical system, somewhat like a telescope. Optics of this focal length, crammed into the small equipment bay of the Angel, represent an outstanding technical advancement in the state-of-the-art of lens design and camera construction. Frequently called a folded trombone optical system, where the light goes round and round, the camera has 6 mirrors and a total of 26 lens surfaces that the light strikes before reaching the 13 by 13-inch film plane. This optical system is one of the several basic new lens designs created for the project by Dr. James Baker of Spica. The lenses were produced by Perkin-Elmer, with Dr. R.M. Scott directing all their project activity. Then Hycon built the camera. The front surface mirrors are coated with pure aluminum. The only cleaning permitted is with tiny, low-velocity streams of air. The C camera has an independently stabilized mount that can move up to 3 degrees in any direction to cancel movement of the aircraft. In older reconnaissance systems, a good stabilization mechanism would normally exceed the weight of the complete camera. By using a radical new concept in stabilization to save weight, space, and power, the complete C stabilizer accounts for less than 75 of the 550-pound total weight. This transistorized unit uses rate stabilization with recentering between exposures. The captivator of the C orients the camera with the airframe just before each exposure, so that the camera will see the same area appearing in the pilot's viewfinder. The camera is then uncaged for 0.8 of a second so that any minute vibrations are canceled before the shutter is tripped. Such stabilization is required because of the extreme focal length of the C unit. A small control stick in the pilot's compartment is used to pinpoint targets either beneath or to one side of the aircraft. A memory delay unit developed by Perkin-Elmer will permit the pilot to select a target as much as 60 degrees ahead and to one side of the aircraft. When the target is centered in the viewfinder, the pilot presses a button and the camera system does the rest. As the plane passes the target on a straight course, the memory delay unit inclines the mirror to the correct side angle and shoots 2 patterns of 4 pictures each that bracket the target. By tilting the mirror 3.5 degrees on the first set of photos, 4 times the normal stereo effect is obtained. The memory unit can handle 3 preset targets at one time, eliminating the need for the pilot to concentrate on the crosshairs of a viewfinder. In another mode of operation, the C camera can follow the undulations of a river or road and will function automatically with sufficient overlap for stereo evaluation once the correct image motion compensation speed is established. The shutter has a circular disc turning at 500 revolutions per minute. The 8-inch disc has a capping blade rotating with it to uncover the opening in the disc for exposure. Shutter speeds are changed from 1/100th to 1/1000th of a second in flight by an automatic exposure meter. Film drive mechanism of the C camera differs in some detail from the other Hycon units, but in practice the operation is similar. Despite the intricate mechanical and electrical systems in this automatic camera, reliability is approaching 100%. The C camera is encased within a nitrogen-filled envelope inside the equipment bay. Thus, the optics of the system are protected from the condensation of moisture or coating from engine oil. Short film clips are processed at Watertown after each flight to check operation of the complete camera system. Negatives from the C camera system have the inherent detail to tell all about what lies on the surface of the Earth, since the camera pinpoints an area of only 1 square mile from 70,000 feet. Negatives clearly show pedestrians, and detail as small as 4 inches can be recognized. The roll of undeveloped film then goes to Rochester, New York, where Eastman Kodak has set up a photographic laboratory specifically for film from this project. To obtain the maximum reconnaissance information from any one roll of film, this lab can develop negatives exposed at sunrise, midday, and sunset, with exposures varying from 100 to 1, and yet retain the high image clarity necessary for photo interpretation. Here, Eastman is turning back the clock to the 1890s, when box cameras were sold with a roll of film installed, to be later returned to the factory for processing. "You push the button, we do the rest," has been one of the best known of American trade slogans. The Rochester lab does the rest by a unique 2-stage developing system in which all film goes through a primary developer, is then dried and inspected by an infrared viewer. Underexposed film is then further processed through 1 or 2 additional developments to bring out details exposed at very low light levels. The combination of trained personnel, photographic chemistry, emulsion research, quality control, and specialized machines yield the information from the Angel's flights. The specialized lab equipment required for this painstaking developing process has recently been modified for field use. The Eastman lab in Rochester is also set up to develop, print, and duplicate film from the 70mm tracker camera that goes along on every flight. The tracker provides a reconnaissance photo record that shows exactly where the Angel has been on its mission. This Perkin-Elmer camera carries 1,000 feet of film and makes a horizon-to-horizon exposure twice each minute. From this record, photo interpreters can pinpoint the aircraft at any point of its flight. A rotating prism with film drawn across a variable width slit make the exposures. A special processing machine for this 70mm film was designed by Eastman and delivers results at 10 feet per minute. A second recorder carried on all flights is part of an S and X band radar monitoring system developed by the Ramo-Woolridge Corporation. It is called System 1 and intercepts signal sources within 350 miles to each side of the Angel. System 1 then records these signals on magnetic tape. The 11.5-pound tape recorder employs a unique coaxial reel structure to minimize both size and weight. It provides a 9.6-hour, 3-track recording on almost 1 1/4 miles of special half-mil Mylar base magnetic tape developed to Ramo Woolrich specifications. One track records signals received from the right side of the vehicle. A second records those from the left, while the third track records a timing tone and special signals when the cameras in the equipment bay are tripped. The addition of only 2 pounds in weight would have eliminated many engineering problems, but the Angel didn't have 2 pounds to spare. Uniform velocity and tape flutter were controlled by precision machining rather than the use of heavy mechanical filters. The System 1 recorder mounts in a small recess beside the pilot's seat. System 1 antennas are unusually lightweight, metallically coated fiberglass materials and mount near the nose on each side of the aircraft. On one of the early flights from Watertown, System 1 tape indicated that a fighter interceptor had approached the Angel at night with its radar fire control system operating. An immediate investigation was begun to prevent further violation of the prohibited area by unauthorized aircraft. 2 other electronic systems, a long-range navigation package and an automatic radio monitoring system, were developed by Ramo Woolrich and test-flown in the Angel at Watertown. Simultaneously, a 4th system was under development, a fully automatic reconnaissance device, System 4, designed to intercept facsimile, voice, TV, point-to-point communications, early warning, fire control, and missile guidance radars, plus many other signal types. The system automatically gives priority to intercepts above 10,000 megacycles. It performs automatically most of the functions of a C-54 load of ferret equipment manned by several human operators. System 4 can intercept both pulsed and CW signals. Upon signal intercept, it records the signal frequency, its relative intensity, the time of intercept, and whether the source appeared to the right or left of the aircraft. The system utilizes this specially developed tape recorder to produce 14 records simultaneously on 1-inch wide magnetic tape. Demodulated signals are recorded on both magnetic tape and photographic film. Film recording provides for extreme resolution of intercepted signal structure. System 4 is extensively miniaturized and transistorized. It employs a total of 25 antennas to cover the frequency range from 141 megacycles to 40,000 megacycles. Except for those intervals when its receivers are locked to signal sources, System 4 is always searching. As with Lockheed and Hycon, Ramo Woolrich worked under the tightest security restrictions with resulting engineering problems. Vendor-supplied equipment, for example, failed at high altitudes and was redesigned by System 4 engineers to avoid explaining why the original equipment had failed. All 4 Ramo Woolrich systems, developed under the supervision of Dr. Burton F. Mueller, have the obvious advantage of being completely passive listening posts. Newly completed duplicating equipment will automatically record 4 copies of an 8-hour tape recording in 2 hours. Then the ground-based job of extracting and pinpointing intelligence information begins. The APQ-56, developed under the direction of C.E. Nobles, surveillance radar project manager of Westinghouse, puts reconnaissance information on the face of a radar scope. This scope face is photographed on a continuously moving strip of film to present pictures like this scene of the San Francisco Bay Area, taken through a heavy overcast from 70,000 feet. The Golden Gate Bridge, the Oakland Bay Bridge, the San Francisco waterfront. AFOT, an air sampling device designed and built by Lockheed, utilizes this nose scoop for one of 3 types of sniffer equipment to record high-altitude radioactivity. Air samples pass through filter paper that traps particles later analyzed on the ground. A second version of AFOT is a gaseous sampling unit. Samples of high-altitude atmosphere are compressed by this four-stage hydraulic pump. An indicator in the pilot's compartment shows the presence of radioactivity. The pilot then selects any one of these 6 reservoirs, and the compressor fills the bottle to 3,000 pounds per square inch. After flight, the compressed air sample is analyzed. The third AFOT system, a particulate air sampler, can also be mounted in the equipment bay in conjunction with the other 2 units. This magazine carries 6 specially constructed filter papers that are placed in the airstream inside the scoop of the equipment hatch. Filters are changed in flight by this record changer, not unlike the mechanism of a jukebox. 3 angels will be assigned to do advanced research in the fields of high-altitude weather, medical equipment, and electronic devices. Thus, the original press disclosure of the Angel as a very high-altitude weather research aircraft proves to be factual. Lessons learned from the Angel are most notable in the field of personal equipment. When pilots fly higher by 20,000 feet than man has ever flown for extended periods of time, equipment changes are necessary. General Don Flickinger, Chief of the Personal Equipment Section of the Air Research and Development Command, took direct charge of the Accelerated Development Program. Equipment originally designed for at the most 5 minutes at 70,000 feet was refined to the point where men could live in it for many hours. Then again, a development program that was going ahead slowly was given a king-sized shot in the arm, and a normal 5 years of work was crammed into 18 months. The Firewell Company has developed an unusual survival kit for pilots of the Angel. Here, the unit is being tested in an altitude chamber that simulates over 80,000 feet. Completely independent of the airplane's oxygen system, the unit is put into use by pulling the green emergency ball. This emergency seat pack consists of a high-pressure storage tank containing sufficient oxygen for 15 minutes and a sensitive regulator to properly control oxygen flow. The altimeter at the left indicates 82,000 feet. In addition, the seat pack contains a conventional survival kit. Before suiting up for high-altitude flights, pilots spend a minimum 2 hours pre-breathing pure oxygen to expel all nitrogen from their systems. High flights without pre-breathing would result in nitrogen bubbles forming in the blood, the painful and often fatal bends encountered by deep-sea divers. Psychological problems have developed. Pilots find the confines of the helmet and faceplate conducive to claustrophobia. A number of pilots have been dropped from the program because of this single factor. During the 2 hours of pre-breathing, the pilot receives a final weather briefing based on the latest meteorological information along his flight route. The flight surgeon makes a routine check of pulse and blood pressure to compare with a record made after the flight. Faceplate problems have plagued the physical equipment people. Condensation of moisture inside the helmet fogs the pilot's vision. Moisture has collected so deep inside the mask that pilots have had to snap the faceplate open for an instant to dump it out. A hazardous operation at best, since failure of the faceplate to properly seat itself will expose the pilot to hypoxia. A fix with a miniature moisture drain was developed. 10 hours at altitude takes a lot out of a man. Pilots are instructed to remain as relaxed as possible while being dressed. All their energy must be hoarded for the flight. Analysis by flight surgeons specializing in high altitude shows that pilots are required to solve as many problems in a single flight as a man on the ground might be called on to solve in 3 or 4 months of 8 hours a day work. The modified MA2 partial pressure suits are personally fitted for each pilot. A loss of only 2 pounds in the pilot's weight could make the suit ineffective, or a gain of 2 pounds would make it almost impossible to get into. Gloves and boots are fitted, and the protective helmet shell is secured. Finally, the bright flying suit is put on. Still breathing pure oxygen from a walk-around bottle, the pilot is ready to be driven to the flight line. Here again, teamwork and training pay off. The slightest deviation from established procedures could cause this flight to fail. Ground crews at Watertown take pride in having their flights leave the ground within 30 seconds of the scheduled time. A checklist of many items must be completed before the engine is started: oxygen, radio, navigational equipment. The fire truck pulls up close, just in case. Compressors on the starting unit come up to speed. A flame ignites in the combustion chamber. Heat waves bounce from the black top of the Watertown flight strip. As the scheduled takeoff time approaches, the canopy is closed. The throttle goes forward to 100%. The wings gain lift. The pogos fall away. Another flight is airborne. Because of the small area of Watertown, the Angel must climb out of sight before venturing out on a long cross-country flight. At this rate of climb, it doesn't take long. During development of the Angel and its primary reconnaissance cargo, a number of significant aids have been developed for the pilot. Without the Lear autopilot and its integral Mach sensor, extended flight would be an even greater strain on the pilot. Developed specifically for the Angel, the Mach sensor keeps the aircraft in a cruise climb condition at a constant Mach number during its entire flight. The Mach sensor keeps the Angel tightrope walking that increasingly narrow line between critical Mach speed on the one hand and flame-out speed on the other. A 7-knot drop in indicated cruising airspeed would cause the older Dash 37 engines to flame out at altitude, while an increase in indicated speed of only 12 knots brings the aircraft to the point of compressibility. The new Dash 31 engine is able to remain lit at somewhat lower ram air speeds, but the critical Mach number of 0.8 still exists. Here, as seen by few men, is what the world looks like from 70,000 feet. These scenes were photographed over Arizona by Ray Gowdy, one of the 5 Lockheed test pilots who have handled all development and production testing of the Angel. Training of new pilots begins with the T-33 for familiarization flights. The pilot must be able to hold the T-bird inches in the air for the length of the lake, so that he will be able to hold the Angel at the same altitude until its broad wings lose all their lift. This mastered, he graduates to the Angel and transition landings on the dry lake. A chase car and chase plane, both with two-way radio, are used during this phase of training. Seat belts in the chase car are good insurance. The new Angel pilot makes at least 3 landings with the pogos installed. She's a little easier to handle that way. Takeoffs are smooth from Groom Lake. A wide circle as the chase plane plays Follow the Leader. Now turn in on final approach, says the instructor in the chase plane. Your airspeed is 92 knots. The chase car pulls into line and picks up speed. He's leveling off just a little high. And at 72 knots, here comes the stall. The best way to land the Angel is in a full stall, just like the old-fashioned airplanes with tail wheels. The broad, dry lake at Watertown makes an ideal location for this type of transition training. After the landings improve, the pogo safety pins are removed, and the new pilot is on his own. Even well-qualified pilots can have their troubles with the Angel. Any lift remaining in those broad wings and she'll go back into the air. However, it isn't long until the new pilots can put the Angel down on the very first try and make her stick, like this. They can even taxi the U-2 right up the runway and turn off on the ramp, if our photographer will get out of the way. Sometimes the drivers taxi right up to the hangar doors. Not bad at all for an airplane that's supposed to be hard to handle on the ground. After a number of day flights, the new Angel pilots are ready for night transition and long cross-country flights. It's no accident that the complete Angel and all its intricate cargo can be disassembled and packed quickly, ready for airborne transport. Everything about the Angel can go aboard a cargo plane. Cameras in their dog houses, engines, lab equipment and supplies, ground support equipment, and, of course, the Angel herself. Men and belongings, too, are air transportable. Thus you have the plane, the pilot, the equipment, and the ground support to put it into the air, all in one neat package to be sent out on wings. The result of foresight and planning, engineering, precise and rapid manufacture. That's it. What it is, and what it can do. A vital chapter in modern American achievement. From the desert wastelands of Watertown, it's but a matter of hours to anywhere in the world where reconnaissance might be desired. The most important airplane, the most important cargo in the air today is in this single package, the Inquisitive Angel.